Section 3.3, Derivatives of Trigonometric Functions. So in this section we look at finding derivatives for trig functions such as sine, cosine, tangent, cotangent, secant, cosecant. And we're going to hit a lot of the trig stuff pretty hard in this section. So if you're feeling like you want to brush up on your trigonometry knowledge, there is an appendix in the back of the textbook, Appendix C, that you can look at. Or if you're feeling completely lost, come and talk to me at office hours, and I can try to bring you up to speed on some of the things you're missing. Some important properties and definitions you need to know are that sine squared x plus cosine squared of x is equal to 1. Tangent x is defined to be sine of x divided by cosine x. Cotangent x is cosine x over sine x. Secant is 1 over cosine x, and cosecant is 1 over sine x. Those 5 things are probably the most important properties. We're going to see them a whole lot. So you need to have those memorized. Need to memorize. And then there's a fourth one I put down here, fourth bullet. This is a addition formula you may have seen in pre-calculus. You do not need to memorize this, but we will use it in class today, or in the video at least, so I wanted to put it down there. So we're going to start by trying to figure out the derivative of sine x, and the way we're going to do this is I'm going to graph sine x, and then we're going to look at what the different slopes are at different points and see if we can figure out what the derivative of sine x would look like. So let's see. Sine, we know, always goes between 1 and negative 1. And it has a period of 2 pi. So let's write pi over 2 pi, 3 pi over 2, 2 pi, and this is 5 pi over 2. And we know that sine starts out at 0, 0, sine of 0 is 0, and then it comes up to 1 at pi over 2, and then it comes back down and hits 0 again at pi. Then at 3 pi over 2 it's negative 1, and then it comes back up, and then it repeats that process. So it sort of looks like that. And of course it does the same thing as you go back. Here's negative pi, negative 2 pi. Comes down, back up, down, etc. So, let's look at some tangent lines. So here at x equals 0, right there, I could draw on a tangent line that looks about like that. And that looks to me like it has a slope of approximately 1. So this is f of x equals sine x, and down here we're going to do f prime of x. So let's still have that be 1 and this be negative 1. What we found here is when x is equal to 0, our derivative will be 1. And maybe I'll put in some of these other things. So there's pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi. Alright, now at pi over 2 we hit a top spot, so our tangent line is horizontal there, and it has a slope of 0. Here at pi, you draw on that tangent line, that looks like it's sort of the same slope as over here, but now it's going negative. So that's a negative 1. Then at 3 pi over 2 we're horizontal again, so it goes to 0. At 2 pi, this is a repeating graph, so at 2 pi we're going to have that slope of 1 again, and then it'll go to 0. So it sort of looks like this. And of course we can do that on the other side as well. Here's negative pi, here's negative 2 pi. It's going to come down and up and down like that. And you should recognize this graph. That looks a lot like cosine x. So from the graph, we guess that the derivative of the sine function is actually equal to the cosine function. But of course, a guess is not a complete answer, so we're actually going to find this derivative for sine x using the definition of the derivative. And I'm going to stop the video here and do that one separate.